sklearnkernelridge. Description: kernel ridge regression is a powerful nonlinear regression method that utilizes kernel functions to map data into higher dimensional spaces, enabling the discovery of complex relationships between features and target variables. It leverages a combination of linear regression and kernel functions to build a model that can handle nonlinear data effectively. Inputs. X. This is the input feature matrix, where each row represents a sample and each column represents a feature. Y. This is the target vector containing the values corresponding to each sample in the input matrix. Outputs. Self. The fitted kernel ridge model object. YPRED. This is the predicted target vector, calculated by applying the fitted model to new input data. Steps. Initialization. The algorithm initializes with a kernel function, which defines the similarity between data points. Common kernel functions include the linear kernel, polynomial kernel, and radial basis function (RBF) kernel. Feature mapping. The kernel function maps the input data into a higher dimensional space, creating nonlinear relationships that linear regression alone cannot capture. Regularization. A regularization term alpha parameter is added to the loss function to prevent overfitting and promote generalization to unseen data. Model training. The algorithm optimizes the model parameters by minimizing the regularized loss function. This involves finding the optimal weights for the linear regression model in the transformed feature space. Prediction. Once the model is trained, it can be used to predict target values for new input data by applying the learned weights and pay kernel function to the new input samples. Metrics. Mean squared error. MSE measures the average squared difference between predicted and actual target values. Lower MSE indicates better model performance. R squared. R indicates the proportion of variance in the target variable explained by the model. Higher R values suggest a better fit. Visualization plots. Scatter plot of predicted vs. actual values visualizes the model's prediction accuracy by comparing predicted and true values. Residual plot shows the difference between predicted and actual values, allowing identification of patterns or systematic errors. Fine-tune parameters. Alpha regularization parameter that controls the strength of regularization. Higher alpha values lead to stronger regularization and prevent overfitting. Kernel choice of kernel function, such as linear, polynomial, or RBF, determines the type of nonlinear relationship the model can capture. Gamma parameter for the RBF kernel that controls the width of the Gaussian function, influencing the smoothness of the decision boundary. Degree parameter for the polynomial kernel that determines the degree of the polynomial function, controlling the complexity of the decision boundary. Uncertainty methods. Confidence intervals quantify the uncertainty in the predictions based on the model's variance. Bayesian kernel ridge regression incorporates prior knowledge and uses Bayesian inference to estimate model parameters and uncertainties. Challenges and fixes. Challenge 1. Overfitting. The model might memorize the training data, resulting in poor generalization to unseen data. Sample use case that resulted in challenge 1. When the model is trained with a large number of features compared to the number of samples, it might overfit the data. Fixes to challenge 1. Increase the regularization parameter alpha. Use a smaller subset of features, or use techniques like cross-validation to evaluate model performance. Challenge 2. Choice of kernel. Selecting the appropriate kernel function is crucial for capturing the desired nonlinear relationships. Sample use case that resulted in challenge 2. If a linear kernel is used for highly nonlinear data, the model might not capture the underlying patterns effectively. Fixes to challenge to experiment with different kernel functions, such as polynomial or RBF kernels, to find the best fit for the data. Utilize techniques like cross-validation to compare the performance of different kernels.